The future of cloud backup in AI-driven workplaces is more than just a conversation about where data is stored. It is about how organizations will manage, secure, and intelligently use massive amounts of information in an era where artificial intelligence powers nearly every aspect of business. Today, let's dive into the trends, challenges, and opportunities that are shaping how cloud backup is evolving to meet the demands of AI-driven environments. To begin with, let's look at the driving forces behind these changes. Workplaces that rely on AI generate far more data than traditional organizations. It is not just raw data. There are model checkpoints, training logs, metadata, experiments, and configuration files. This creates a much more complex environment for backup systems. Companies cannot afford downtime when their AI pipelines are running, and restoring the right model or dataset quickly can mean the difference between innovation and disruption. On top of that, the threat landscape is evolving. Ransomware, insider threats, data poisoning, and model theft make it essential to ensure backups cannot be tampered with or compromised. At the same time, regulations around data privacy, data residency, and auditability are becoming stricter, pushing companies to think carefully about how their backup systems align with compliance requirements. Finally, storage and bandwidth costs continue to rise, forcing organizations to find smarter, more efficient ways to manage their backups. Now let's explore the innovations and trends that are shaping the future of cloud backup. One of the most exciting developments is the rise of autonomous, self-healing backup systems. These systems can detect errors, failed snapshots, or data corruption automatically and repair themselves without manual intervention. This leads to greater reliability and reduced downtime. Another trend is context-aware backups. Instead of simply saving files, modern systems can capture the entire environment around an AI pipeline, model versions, dependencies, metadata, and data lineage, making it possible to restore not just the files, but the full state of an experiment or project. We are also seeing intelligent data lifecycle management powered by AI. These systems analyze how data is being used and automatically decide what needs frequent backups, what can be archived, and how long each dataset should be retained. This greatly reduces storage costs and improves efficiency. Another key innovation is anomaly detection built into backup workflows. AI monitors backup access patterns and flags unusual activity, such as mass deletions or unauthorized access attempts, and can even isolate or roll back compromised backups before damage spreads. Immutable and verifiable backups are also becoming the standard. By ensuring backups cannot be altered and using cryptographic methods to verify their authenticity, organizations can trust that their backup data is accurate and secure. Beyond that, the speed of recovery is improving. Future systems will allow granular restores of very specific elements, like a single model checkpoint or configuration file, without having to restore an entire environment. This is especially valuable in AI development, where one missing dataset or corrupted file can halt progress. Integration with AI pipelines is another big shift. Backups will not be standalone anymore. They will be built into MLOps tools and machine learning lifecycles, ensuring that every experiment, checkpoint, and dataset is automatically backed up in context. Finally, AI-assisted search and discovery is emerging. Imagine being able to search through your backups using natural language, tags, or even image recognition, and instantly finding the dataset or model you need. That kind of accessibility transforms backups from being a safety net into being an active tool for innovation. Of course, these advancements also bring challenges. Data privacy remains one of the most critical concerns. If AI is analyzing backup data for optimization, organizations must ensure sensitive information is properly anonymized and protected. There is also the issue of bias and false positives in anomaly detection systems, which can generate too many false alarms and reduce trust in the system. The complexity of these intelligent systems introduces a skills gap as well. Not every organization has the expertise in AI, cloud infrastructure, and security required to manage these environments. Cost is another challenge. While intelligent systems can optimize storage, AI-powered monitoring and multiple backup versions consume resources. If not managed carefully, expenses can escalate quickly. Integration across heterogeneous environments is also difficult, since many AI-driven workplaces use multiple cloud providers, on-premises systems, and containerized workloads. Ensuring consistent policies across all of them is no small task. Lastly, the backup systems themselves must be secured, because they are valuable targets for attackers. If a backup system is compromised, the entire safety net is gone. So what can organizations do to prepare for this future? First, they need to design backup policies that capture not only data, but also the full context of AI pipelines. This means versioning code, model weights, and metadata alongside datasets. Second, tiered storage strategies are essential. Frequently used data and checkpoints should be stored in hot backups for quick access, while older information can move to colder, cheaper storage. Third, organizations must embrace immutability and encryption. Backups should be tamper-proof, encrypted at rest and in transit, and governed by strict access controls. Monitoring is another critical step. AI-driven anomaly detection can flag irregularities, but organizations should combine this with proactive security measures, such as offline backups and isolated recovery systems. Regular recovery drills are also important. It is not enough to assume backups are usable. Companies should practice restoring AI environments to ensure they can reproduce models and data when it matters most. Compliance and governance must also be central. Keeping track of where data is stored, how it is accessed, and maintaining logs for audits are necessary for both legal and ethical reasons. Finally, organizations should invest in skills or consider managed services that specialize in AI backup and security. What does the timeline look like for these changes? In the next 1 to 2 years, we will see wider adoption of AI-assisted features such as tagging, anomaly detection, and integration with machine learning pipelines. Cloud providers will introduce more immutable backup options and smarter retention policies. Over the next 3 to 5 years, backup systems will become increasingly self-managing, adjusting policies automatically, supporting seamless cross-cloud operations, and offering cryptographically verifiable data chains. We may also see new regulations focus specifically on AI pipeline backups and model provenance. Looking further ahead, 5 to 10 years from now, backup systems could become fully embedded into every layer of AI infrastructure. Recovery and protection may become completely autonomous, with AI agents capable of rolling back environments, isolating threats, and maintaining continuous integrity checks without human input. In summary, the future of cloud backup in AI-driven workplaces is not just about keeping data safe. It is about building intelligent, adaptive systems that ensure continuity, security, and compliance while empowering innovation. Organizations that embrace these changes will be better prepared to handle the complexity of AI workloads, protect against evolving threats, and unlock new efficiencies in their operations. Those that ignore these shifts risk being left behind in a world where data and AI are the lifeblood of success.